This video provides with information for the startup of thermocouples. Besides general hints, the video gives information about the wiring, the linearization in the field devices, and the temperature compensation. A thermocouple consists of a combination of two metals. Their transition point is exposed to the measuring temperature. Due to the different thermoelectric behavior of the metals, a thermoelectric voltage results at the transition point. The thermoelectric voltage is a measure of the measuring temperature. The thermocouple is connected to the automation component at the terminal point. Due to the material transitions, two thermoelectric voltages result. The sum of the partial voltages is a measure of the temperature T2 present at the terminal point. The field device measures a voltage proportional to the difference of T1 minus T2. For this reason, the terminal temperature T2 must be measured and added to the measured value. In JUMO field devices, therefore, a RTD temperature probe is located close to the terminal. The RTD temperature probe measures the terminal temperature T2. T2 is added to the measured value T1 minus T2. This process is called internal temperature compensation and is used to determine the measuring temperature T1. Regarding to the thermocouples, the terminal connection is called reference junction. Correspondingly, the temperature at this point is the reference junction temperature. For JUMO field devices, so-called setup programs are available. These programs are used to configure the devices. For the respective input, probe type thermocouple with internal temperature compensation must be selected. The selection of the thermocouple used is carried out under linearization. By means of this selection, the associated temperature is automatically formed from the measured thermoelectrical voltage. A selection of thermocouples is defined. The voltage characteristic and tolerance of the respective elements are standardized. Here the symbolism of the thermocouple is shown. The minus leg is drawn thicker. As described, a second thermoelectric voltage arises at the device. Internal temperature compensation takes place by measuring the temperature of the reference junction. For the internal temperature compensation, it is important that the thermocouple is extended with the wiring. The wiring material corresponds to the material of the thermocouple. If the material exactly corresponds to that of the thermocouple, this is called thermowire. In the case of substitute materials, which have the same thermoelectric behavior, the wiring material is called compensation cable. The wiring material has a plus and a minus pole as well, and the connection has to be made accordingly. At each material transition, thermoelectric voltage is generated. This must be considered for the wiring technology of the compensation cables. When connecting wire-Lyster terminals, there are two voltages which are opposite. If the same temperature is present at both junctions, the voltages are equal and cancel each other. Since in most cases it cannot be reliably assumed that the temperatures have the same value, it is recommended to use connectors free from thermoelectric voltage. These connectors have the same thermoelectric properties as the compensation cable, and as the name implies, no thermoelectric voltage is produced. There must be chosen the particular connector for the thermocouple in use, and the polarity must be considered. If the thermocouple input is open, a voltage of 0 mV is present on the field device. This corresponds to a temperature of 0 centigrades. The field device indicates the negative reference junction temperature. JUMO field devices operate with a test current, which is fed at regular intervals through the measuring circuit. If no test current can flow, the thermocouple input is open. With this procedure, the open input is detected. In the event of a short circuit in the compensation cable, a second thermocouple is produced. The parallel connection of the two elements results in a temperature which lies between the measuring temperature and the temperature at the short circuit point. The short circuit cannot be detected. Two thermocouples are used for safety-relevant application, such as the use of safety temperature limiters. The temperature of the thermocouples is measured by two separate inputs, and the temperature deviation is determined. If a temperature deviation defined in the field device is exceeded, an error message is indicated on the field device. Respectively, the process is switched off. A short circuit in a compensation cable is detected in this way. Thank you for your attention.